So in this article, he describes the idea that they create this constant lap from the ground up for 1 kilometer up, 1,000 meters up, right? They keep the medium through which you're looking at a constant. It doesn't change for 6.5 degrees until you get to 1,000 meters. Does that make sense? Okay. So this was suggested by Professor Toussaint for the convenience of calculating airplane performance and artillery firing tables. Young notes, the early motivations for this simplified model were evidently the calibration of aneroid altimeters for aircraft and the construction of firing tables for long-range artillery where air resistance is important. Now get this, we're talking about artillery fire, which goes to high altitudes, aircraft flight, which goes to high altitudes. We're not even talking about looking across a corridor, which is roughly just 2 to 3 meters off the ground, right? We're talking about looking at 2 to 3 meters across the surface of the Earth until we get to the point of the horizon. So all of this standard atmosphere is applied to thousands of meters above us, which we're not dealing with because we're dealing with things that happen on the horizon. So the standard atmosphere wasn't even created for these observations that they're applying to the horizon. Young further critiques the applicability of this model for refraction calculators near the horizon, saying, unfortunately, it is precisely the inaccurate region below 1,000 meters, the 1 kilometer area that we're talking about, the inaccurate region below 1,000 meters that is most important for refraction near the horizon. Let me say that again. Unfortunately, it is precisely the inaccurate region below 1,000 meters that is most important for refraction near the horizon. However, the Toussaint lapse rate, which Greg calls arbitrary, that's scientific, isn't it? However, the lapse rate is so embedded in many altimeters that it cannot be altered. All revisions of the standard atmosphere have preserved it. That is, they've assumed something to be true, and they just continue to apply it carte blanche to all of their ideologies in terms of what's happening in our world. Young concludes that the standard atmosphere is inappropriate for astronomical refraction calculations and suggests that a more realistic model would include diurnal changes in the boundary layer, though these are still poorly understood. Do you hear what's happening? We have had hundreds and hundreds of years of this research, and we still have within articles being written today by the foremost expert, Andrew Thomas Young, where he says that these things are still not understood. He doesn't even know how to make predictions. I've asked him. He cannot predict anything about what, and that's the scientific method, is it not? You have an hypothesis, you have an experiment, you have a test, you verify, and you can demonstrate your claim. Andrew Thomas Young cannot demonstrate his claim. He cannot show us reality, which I can do. If you wanted me to break down all of these ideas about looming and sinking, towering and stooping, and mirage, I could, with all of my thousands of field hour experience, I could show you my scientific claims with reality. Andrew Thomas Young has to draw you pictures of triangles that don't exist in nature. So when you see him show you an example like this, no, where is it? When you see him show you an example of looming and sinking, sinking is so close to the standard atmosphere that this is the apparent top of the house that we should see. Why? Because this house, I'm now imposing this observation, right? The floor of this Chesapeake Bay, the surface of the water from my feet to the shoreline of the Red Roof House, this is 10 kilometers away. Okay? Andrew Thomas Young models 10 kilometers with this not to ratio curvature. And he shows you that the Red Roof House, which is 10 kilometers away, this line right here represents the visibility allowed due to the, right here, this is where the curvature of the Earth right here is blocking 2/3 of the target. Here I am standing at Concord Point at just under 2 meters of height, and I'm looking out into the distance. Doggone it, the horizon got in the way. I can't see the Red Roof House. No. It's right there, every single time. The only time I don't see the shoreline like this is when the refractive index changes, like this. And now, this would be more difficult for me to see at a distance, right? And then this would even be more difficult for me to see. This is the Red Roof House. These are different refractive indices. Here's a sailboat. Can you see the hull? It's right here. But if we were looking 6 miles away, you probably, and I could show you videos of this, wouldn't even be able to see that sail unless you were specifically looking for it, if you knew it was there. But if you just looked up, and you wouldn't see this sailboat because of the refractive index. There's no curvature here. I'm looking at the hull right here. There's no curvature. I should never see the hull of any ship across the Chesapeake Bay at this distance, ever. Here we have another example. Now, I said before that when I go out to set up at the at Concord Point and I look out, I always see something of the Red Roof House. But the only reason why I never see the entirety of it is when there is a mirage. Otherwise, here's the entire house. 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 And there's another sailboat right there. Different refractive indices I'm seeing directly always. I never should, because in the standard atmosphere model, it should be sinking. It should be behind the horizon. But the only time I never see the entirety of the shoreline, because we don't have the Red Roof House in the mirage just yet. There's a little bit right here, and the fold line is here. However, the house itself is intact in terms of its being a 100% target, right? But here we have the Red Roof Pavilion, and we can't see the shoreline. So it looks like the water is cutting off the shoreline, but it's not. Because right here, the reason why we have this termination, it is an optical phenomenon due to mirage. Mirage is creating the limit to the visibility of the water. When we get right here, here's a sailboat. Where's the hull? Where's the hull of the sailboat? If you were to show this to anyone who was a globe science warrior, he would say the sailboat is behind the curve. This is curvature to him. It's not. It's 100% a refractive phenomenon known as mirage. And the mirage is very acute. It's a very severe angle to the mirage. However, that severe angle is extending over the floor of over which you are looking until it gets to the target. So this little tiny refractive display of mirage right here could be miles of distance between this point right here and the mirage, just for instance, okay? So this is what the Red Roof House should look like in Andrew Thomas Young's modeling. Okay, so I've put it right here. This is the way, according to Andrew Thomas Young, in the standard atmosphere, because sinking is very close to the same refractive index. Don't know how they figured that out, because he has nothing to show you of like, oh, on this particular day, at 10:28 in the morning. We took all of these measurements. This is the condition. He doesn't have any of that. He's just modeling, well, if the light does this and if the light does this, how can we make the thing that we see out there match the way that we're modeling it? Well, I can tell you one thing is, get rid of this curve, because that has nothing to do with why you can't see the house. Let me tell you this. If this is the standard atmosphere that is relatively close to what we should always see, I've never seen the house look like this. Never, ever. It doesn't make, why, how would that be in a scientific empirical world where science says that the standard atmosphere, which I've never observed, why would I say that? Because I've never seen this image. 10 kilometers away, he's showing me at 10 kilometers, this is what your target should look like. Never. And then when it gets loomed up, when the refractive index brings it up over the curve, it never brings the entire house. This is what looming looks like. This is what sinking looks like. Looming, sinking, looming, sinking. But we're never going to see the entire house, and we're never going to see the shoreline. Ever. In this model. And yet, here we are. Every single time. The only reason why I don't have an image like this when I go out, even though I can see the red roof house in front of me, the only time I don't have an image like this is when the refractive index changes like this. But I'm looking out straight across, and there's another sailboat, and there's the shoreline, and there are pavilion tents that, or maybe beach tents that other people, this is the beach right here. Are you hearing what I'm saying? Every single time I look across the Chesapeake Bay, I am always looking with a direct line of sight to the shoreline. The only time I can't see the shoreline is when the refractive index distorts it or displays it and obscures it through mirage. All right, let's go back to this real quick and see if there's anything else I want to say. All right. So I'm going to just leave it at that and see how well this does. All right. So I want to continue to assist you to understand how you have been duped into interpreting the limitation of your vision at the horizon. You have been duped. This is the emperor's new clothes. You have been duped to believe that the emperor, the horizon, is the curvature of the earth, that the emperor has clothes on. I'm the 8-year-old boy saying, that's not earth curvature. That's the limitation of your visibility due to the conditions of the medium through which you are looking, which medium is affectionately known as the ether band. Everybody drink. As we wrap this up, if you would like to see more specific debunking through Andrew Thomas Young himself, let's get this video to 500 Fonzarellis. All right, if you're at this point right now listening to the sultry sound of my voice, first of all, thank you very much. Second of all, would you be so kind as to smash that Fonzarelli, hit that like, let's get it up or beyond 500, which means you have to share the content. Please, please, please share the content, and I will divulge, I will disclose the emails that I have had with Andrew Thomas Young where he says things like, you're taking my modeling experiments too seriously. I have been your host, Travel Mateus. Until next time.